is question number 4, which says find the gradient of the curve at x is equals to 3. Okay, gradient means dy by dx. First, what I'll do is bring the denominator up by making its power minus 1. Initially, you can say that it was x square minus 4x bracket 1 and bracket power 1. When it goes up, it becomes power minus 1. So now this is a function. There's a 12 outside, and then there's a function fx power n, and we need to derivate this function. So it's going to be n fx power n minus 1 times f prime x, which is the derivative of fx. And nothing is going to happen to the 12, it's going to stay 12. So dy by dy by dx would be equals to 12 stays 12, power comes down, minus 1, power gets reduced by 1, so minus 2 times f prime x is going to be the derivative of this, which is going to be 2x minus 4. So we have a minus 12 here, a 2x minus 4, and this can be taken down to the denominator, and we get x squared minus 4x whole squared. This is dy by dx. Now we need to find the gradient when x is equals to 3. So you substitute 3 and enter all of these values in the denominator. If you want, you could open the brackets as well and write minus 24x plus 48, or you may not. And when you substitute everything, you should get minus 8 upon 3. Okay, now let's do part B. Which is that a curve has this equation, y is equals to 4 upon square root of x. I'm writing it as x power minus half because when it comes up, the power half becomes negative half. The normal to this curve. So there's a curve. I have no idea what it looks like. Let's assume it looks something like this. Okay. So there's a point 4 comma 2 here. Okay. And there's going to be a tangent at this point 4 comma 2. Okay. If there's a tangent to this point, that means there's also going to be a normal to this point, which is going to look like this. So we need the equation of the normal. But to get to the equation of the normal, we first need the gradient of the tangent, which is dy by dx. So what are we doing? We're first finding gradient of the red line, which is dy by dx. So the minus half is going to come down, 4 times minus half, and the power is going to get reduced by 1. That would be minus 3 upon 2. Okay, so we have minus 2, x power minus 3 upon 2, and this is the expression for dy by dx, and the slope of the tangent would be, when you substitute x is equals to 3 in here, use your calculator, and when you do that, you should get, sorry, the point is 4 comma 2, my bad, not x is equals to 3. That was from the previous part. Okay, so you substitute x is equals to 4. That should give you minus 1 by 4. So the gradient of the tangent got calculated through dy by dx. It came out to be minus 1 over 4, which means that the gradient of the normal would be negative reciprocal of this, which would be 4. And this point is same for both of them. It's 4 comma 2. It's going to be used to find C of the normal, the y-intercept. Okay, so now we find equation of the normal. It's going to be y equals mx plus c. To find c, you need a point on that line. We're using 4 comma 2. That's the only point we know. So this would be what? Minus 14. So y equals mx plus c. Okay. Just give me a quick second. Okay. So after that, it says that this normal meets the x-axis at P. So if this, assuming this is correct, this would be P and this would be Q. And we need to find the length PQ. That means we first need the coordinates PQ. And we know that on the x-axis, y is always equals to 0. And on the y-axis, x is equals to 0. So to find P, which is on the x-axis, we will substitute y is equals to 0. So when we do that, when we write 0 is equals to 4x minus 14, it gives us x is equals to 14 upon 4, which is 3.5 or 7 over 2. So the coordinate of P is 3.5 comma 0. Okay. Similarly, we need Q. So for Q, we're going to replace x with 0. For Q, x is equals to 0. So we have y is equals to minus 14. So Q is 0 comma minus 14. Okay. Now all we need to do is apply the distance formula on these 2 points. So square root y2 minus y1 whole square plus x2 minus x1 whole squared. So square root 0 minus minus 14 would be plus 14 whole square plus 3.5 minus 0 whole square, which gives us 14.4 after rounding.